We are at lesson 3.4, Anatomical Evidence. So as always, feel free to pause the video, write down your learning goal, and then press play whenever you are ready to continue. So our big question for today is, how do we know that species are connected through evolution? Well, one way is by looking at something called anatomical evidence. And that's just a fancy term for comparing body structures. So let's do a quick vocabulary review before we jump in. We're going to go over two words. The first word is structure. So what does it look like? What is it made of? My hand is a structure. It has 5 different points. It has nails. Describing the structure and drawing it is what it would be. But its function, its job, what does it do? It grabs things. It picks it up. So we're going to be constantly referring to structure and function in this. Ghetto background, y'all. I live in Canarsie. Okay, so let's go with our first guiding question. What do a whale, a bat, and a human all have in common? Well, at first glance, you would think like nothing. They're all organisms. I don't know, they're all alive. But if you really look beneath the surface, their bones tell a surprising story. So let's take a look at the skeleton of them all. Ooh, we have a lot of things common in our skeleton. So, for example, if we look at the bones in a human arm, a bat wing over here, a whale flipper, and even a cat, you'll notice they all have the same type of pattern. There's one bone at the top. There are 2 bones in the middle here. And then you're going to see smaller bones for the wrist. And they kind of all use these parts differently. So with our hands, we grab things. Bats fly with their hands. Whales swim. But even though they all do different things, the bone layout is nearly the same. And that's not a coincidence. That is the evidence of a shared past. That is the evidence of a common ancestor. So let's break it down even further. If we look at the human arm, we're going to see that the humerus is almost the same thing here, right? And even though these bones are slightly shaped different, their structure is different, the pattern is the same. So again, even though we grab, bats fly, whales swim, cats walk, these limbs are made from the same bones in the same order. And all of this is evidence of a common ancestry. So we've been talking about it, right? If 2 animals have body parts that look the same but don't always work the same, doesn't mean it's related. Let's investigate that a little bit more. So we have 2 definitions here at the top. We have homologous structures, and that root word homo means same. So when there is let me annotate that. Is the same type of structure. So this shows a common ancestry. That basically means that over here, the limbs have the same structure, the same layout. But an analogous structure means that they have the same function or they have the same job. So for example, sharks swim. Penguins also swim. Dolphins also swim. So their fins are for swimming, but they are shaped different. Their structures are different. So homologous structure shows common ancestry, but analogous structure shows that the function of needing to swim was similar in their different environments. So now let's take a look at exactly what does anatomical explain? Why does it matter? So because these homologous structures suggest that these species didn't just randomly grow the same bones, instead it shows that they are inherited from a common ancestor, a species from the past that had the same limb structure. Over millions of years ago, evolution, specifically natural selection, caused these limbs to change and adapt depending on how the animal has lived. But the basic bone layout has stayed the same and has been passed on for many generations. Again, anatomical evidence is very strong that supports the theory of biological evolution, that all life is connected and changes over time has happened.